This episode is brought to you by BEAMOps. If your Elixir deployments are painful, or your infrastructure is a mess, or you just need experienced hands to help you scale, these are your people. BEAMOps specializes in scalable Elixir development, automated deployment pipelines, and infrastructure migrations. They will help you work smarter and ship faster. As authors of the Prog book, Engineering Elixir Applications, they know their stuff. Check them out at beamops.co.uk. Coding Elixir with AI or building AI into your Elixir apps? The Elixir AI Collective Discord is your community for both. Link in the description below. Testing. What's up? I'm Jacob Litzo, your Elixir mentor, and welcome to another exciting episode of the Elixir Mentor podcast. This is where we discuss everything related to Elixir, from interviews with enthusiasts, pioneers in the community, to innovative projects and libraries shaping Elixir's future. Today, I'm joined by Mark Cotner, telecom engineer, open source contributor, and the person behind something big in Elixir, Observability. Thanks for joining me today, Mark. I'm excited to chat.
It's good to be here.
To kick things off, do you want to just tell us a little bit about yourself, like where you're based, what's your background, and what your day-to-day looks like?
Sure. I'm in Atlanta, Georgia. My day-to-day is pretty busy. I have basically two full-time jobs. I'm a DBA for Mannheim Auto Auctions, which is largest auction provider for used cars in the United States. And at night, I have about 1,000 databases or so. And at night and weekends, I am a CTO of a startup. So the startup is, we do small cable plants. We do mostly hospitality networks and, 200 to 300 modem small networks with cable modems.
That's awesome. Very cool. What ended up getting you into that space?
That's where I started. My background is cable. So
Okay.
I started, my first cable modem was a one-way download only ISA card that you used your dial-up for uploads. So yeah, I've been in the cable industry for a very long time.
I remember dial-up. I also remember when like ISDN came out and it, like being permanently connected to something became a thing. That was cool.
Yeah, actually, so I started very early in that, and I sat for the DOCSIS steering committee
Oh,
for
nice.
Cox Communications back in the day. So the DOCSIS is the cable modem protocol that actually
Okay.
operates the cable modems. So yeah,
Gotcha.
I've been around it for a very long time.
That's awesome. For a minute, like in high school, it's been a while. I did some Cisco networking stuff and I don't remember any of it. But I learned a lot. I remember that and it was good. I'm curious, what was your background? Like what got you into like the cable modem and then into databases? And now you're writing Elixir, I'm guessing, with the hospitality stuff, right?
I am. So originally, I started as sort of a sysadmin network engineer for the cable modem side, and then I became a specialist and started doing the steering committee. And as part of that, I decided we needed better observability in our cable networks. And so I built an application that helped with that. And so it was used for every single call. Like if you were a Cox cable customer and you called in, our app was what basically helped them troubleshoot your cable modem and see how it was feeling today and all that stuff. So um, that, of course, required a very large database. And so I got a lot of attention in the MySQL space. This was a MySQL database back in the day. Got a lot of attention back in the day for MySQL. And so I helped them get their second round of funding, made them a lot of money. And so just after that, I was asked by Mannheim was having some performance issues on their databases. They asked me to come over. Mannheim is also part of the same company that Cox Communications is, and
Okay.
so I came over from Cox Communications to Mannheim to help them with their databases, and that was 6 8 databases at the time, and now it's 1,000. But but that's how I became a DBA. during my day job is I built an app that basically gave us observability for cable modems. So my background is definitely observability, and that's why I wrote Timeless, the observability databases, right? So there's a Timeless Metrics, which is a metrics database. There is Timeless Logs, which is a log compression, log ingestion, allows you to search database. And then there's the traces, right? So I ingest all the traces, and then you can go and search for traces and look them up and stuff like that. Very high compression, very low CPU overhead, which is why I sort of pursued the embedded side, which you guys will see later. And so you can just embed your observability right in your Phoenix app is the goal.
Yeah, that's really cool. Yeah, you sent me a demo right before this and I was trying to watch it. But to be honest, I was like watching it and also multitasking, so I probably absorbed like 10%. But it seems like it seems really cool. So like I guess we'll shift to your observability engine a little bit here first. Um why that and what makes it so complex?
So I was actually putting together Ansible scripts to deploy some of our apps on the ISP side, the CTO slash my night job, and it was a bit more difficult than I was expecting to get the Ansible just right with the stack that was highly available. It had metrics, and I was using Victoria metrics at the time, and which is fantastic. I don't necessarily want to compete with them because they're quite good at what they do, but yeah. So it was just really difficult to sort of get all the Ansible right, to get it high
Mm.
availability, everything that I wanted. And I was like, you know what, this should be easier, because 99%, 95% of apps don't really need external observability stacks, where you're pushing your logs to a server, you're pushing your traces to a server, you're pushing your metrics to a server. So, I needed a high performance. It has to be high performance if you embed it, because you don't want it to take away from the app's ability to serve, right?
Yeah, that makes
So
sense.
it needs to be like Rust or something like that, Rustler. And so, basically just a really lightweight observability stack that compresses really well, that you can just run inside your application. I even added an in-memory mode, so that you could do it with, say, a Nerves app. You don't want to
Oh, that's
necessarily write
cool.
metrics to your SD card, right? Because those things don't necessarily take a lot of writes. And so there's an in-memory mode, so you can actually just take the metrics, compress them, and just store them in memory, which is pretty cool as well.
That is cool. I don't remember who I was just talking to because all my podcast guests kind of mesh. But that we were talking about like if you want to like up your software engineering game to work on embedded systems because you have limited resources, which is something
Yeah.
we're not very used to anymore in
Yeah.
the software world because we just throw more and more RAM at it or more GPU, whatever we might need.
Yeah, there's a number of things that I've written, that are to run on routers, which is the same, right? You just need it to be as small as possible and take up this
Yeah.
the least amount of memory as possible. So yeah,
Yeah, that makes
it's the
sense.
same concept. Yep.
And like a router has to always work too. Like, you plug it in and it needs to just start doing its thing.
Yeah, you can't interfere with it passing packets, right? That's the
Yep.
most important thing that it does.
Yeah. Yeah, that's cool. I feel like I really appreciate like people that do the observability stuff and everything because I feel like it's something I don't want to think about, but it's really nice to have those metrics and logs when you need them. Cause
Yeah, well, go ahead.
oh no, I was just yeah, continue.
Well, the nice thing about this is it's Igniter, right? And so you don't have to think about it. Like it's I mean, you probably saw it from the part of the demo that you were able to watch. It takes less than 5 minutes. It's one of the first things you do when you start up an app. You just say, hey, you run an Igniter script that does all the wiring for you. It starts ingesting your logs. It starts ingesting your traces. and it starts ingesting your metrics, and it does it all for you. It's pretty great.
Yeah, that's
Igniter is just
amazing.
an amazing addition to the
Dude,
ecosystem for
Igniter's so
Elixir.
cool. It's so
Yeah.
cool. That and usage rules. Like those are like I think my two favorite, like just they're like such simple libraries that are so powerful.
And the nice thing about this too also is that, because I wanted it to be embedded, I've actually made the performance so good that it actually runs really well as a standalone. You could actually replace your entire observability stack from, say, Victoria metrics, logs, traces, right? You could just replace that with a single server, and it would ingest, millions of entries per second. I was watching the Tiger Beetle demo this week that's been making its rounds around the internet, and they talk about 1 trillion transactions and all this stuff, and you look at it, and it's only doing 500,000 transactions a second, which sounds like a lot, but it's really not compared to what metrics ingestion is at today, right?
Yeah.
Yeah, but we get around 3 million metric ingestion, metrics per second,
Okay.
and we can do 1 million logs per second. Obviously not at the same time, but each individual server is capable of these, and I think traces were up to like 800,000 per second or something like that. It's
Okay.
it's a big number.
That is cool.
Um, yeah,
Where like I'm guessing like the compression side of things is like the huge bottleneck, right? Or no?
it's actually not. The compression has advanced in so many ways the last few years. I've obviously been following telemetry for a long time, 30 years now. But really during COVID, I think every smart person, smarter than me, certainly, every smart person just sat at home and just figured out great ways to compress things and use CPU offloading. There's uh, kind of like MMX extensions, right, for
Mm-hmm.
CPUs. Neon for ARM 64. There's basically CPUs do some acceleration there. And so
Okay.
you can actually do it even down to the Pi. Even Raspberry Pis will do some hardware acceleration for that.
Okay.
So
That's
it's
awesome.
become really nice. We'll just say,
Okay.
and there are lots of options, which is why this has taken me 2 years, is because there are so many compression options for logs and traces, and I actually split. There's something called PCO, which is the compression that we use for metrics, which is fantastic. You usually get over 10 to 1. It's I think around 14 to 1 right now on my test bed. And then getting 10 to 1, 9 to 1, something like that for logs and traces is really good. And we use OpenZL for that, which is a columnar compression that's actually format aware, which is really cool.
That is that's cool. So what's the biggest bottleneck then for like your ingestion rate? Like what are you competing against to get that number up?
So it's been a journey. So I've been pulling off pieces and doing NIFs, right? And I would do some CNIFs. I actually built a little web server. It's called Rocket. That was a little faster, actually quite a bit faster, 30 times faster from a latency perspective than Bandit. And so I've just been pulling pieces apart. I find a bottleneck and I'll write a NIF for it. Um, and the problem that I ran into was I kept pulling pieces off and writing NIFs for them. But then when the NIFs would have to talk to each other, they would have to go through the Elixir layer, and there's a translation layer there. And so that became slow. And so what I did was I pulled enough pieces off now, I can just meld the pieces together and just make one NIF, right, that does most of the work. And then there's just that one translation layer that goes basically from Elixir down to Rust
Okay.
on the metric side. And so, yeah, the bottleneck is sometimes the translation layer between Elixir and the NIF, and that's really just to tell you how much we're slicing the time here. That's where our bottleneck is.
Okay.
Yeah.
Like I'm curious then, would the next step be like is Elixir your bottleneck? Or
There's no,
no? No?
no. Orchestration in Elixir is just so good. I would never
Ye-
consider no.
Okay.
Yeah, the ability to do clustering, just the niceness of, I mean, we're all here because Elixir is fantastic for orchestration, right?
Mm-hmm.
And so, no, I think this is definitely an Elixir application from beginning
Okay,
to end.
cool.
I've gotten the performance that I feel like I need out of it. I feel like I could do Facebook scale. I could do all the things that you need to do with the number of nodes that they have doing ingestion anyway, in AWS scale. So
Yeah, that's
uh, I
awesome.
think I think I think it's fine,
Yeah.
and it works great. And it's really nice to have it in Elixir because you can do things like this embedded side, right, where you just drop it into your app and it ingests and gives you all of the intelligence that you need for your app, traces and everything, for nothing almost, right? I mean, it doesn't
Mhm.
really cost you anything. It's less than 5% probably load on top of your app. So.
That's awesome. Cool. Now, how does Timeless work its way into your hospitality business? Does it? Did you build it
Oh
for a
yeah,
reason? Yeah.
we have about 10,000 cable modems.
Okay.
We have about 1,200, or we'll have 1,200 lines very shortly, of telephony. And so we have metrics that we collect on all those things, and we want observability for those. And
Mm,
that was what it was originally written for. And so I thought I would share it with the world and see if either other people find value. But we'll be ingesting quite a few metrics. We'll have about 200,000 series, maybe 300,000 series that we'll put into it. And
okay.
series is just a metric over time, right?
Yeah, yeah. Cool. Um, to go into the hospitality network business, like paint me a picture. What does it look like? Like what does the actual network look like? Like does I don't know if I made this up or if we talked about it, but like some of your clients would like include like RV parks,
Mhm. No, that's accurate.
nursing homes, hotels, like all of that.
Yeah,
Okay.
we call them multi-dwelling units,
Okay.
MDUs. And so it's just a number of whatever, right? It could be
Hmm.
apartments, it could be nursing home, it could be anything. And it's like just a small cable company. They have a router, a cable router, that we directly import from China. We brand it. We have our own brand.
Oh,
Um,
nice.
and we do all the provisioning for that, and the observability, right? So we help integrators who will go out and do the installs. We help them with all of the things that are hard for them to do, right? It's easy for them to travel and do and understand networks well enough to set up the networks, but we take over and make sure that it's healthy and stays healthy and stuff like that, and sell them the hardware. So it's basically just tiny little cable companies that we build, that are 200 or 300 modems or something like that.
Yeah, okay. That's cool. So like an apartment complex, for instance, you would have like do you have like a main entry point closet and then kind of splits off to every building and then every apartment and
Yeah, and it will use, like, a lot of times those apartment complexes already have cable run, and so it'll use their existing. They won't have to run fiber, they won't have to run
mm,
Ethernet or any of that stuff. It just operates over cable modems.
okay. And then it's your own hardware or your branded hardware at least.
Yeah. Yeah.
That's cool. And then are you embedding timeless into your hardware or how's that
hmm
working?
No, we pull centrally, and so it's
Okay.
going to be there's a version of Timeless that embeds into your Phoenix application, and it's designed to be really small, take very little memory, very little CPU. There's also the server version, right, which will consume as much memory as you give it, just like any other database, and will return results quite a bit faster. And that's what we have as central. Yeah.
Okay. Okay, I see. That's cool. Now, mentioning like you've had 100% annual growth.
Oh yeah.
That's wild.
Yeah, that's not necessarily me. I'm late to the game. I just
Okay.
joined the company recently. I'm the CTO, but the CEO has been growing the company for about 7 years, and he's gotten to a point now where he's about 100% year over year, and people are. It's really advantageous for them because again, it uses their existing cable plant, right? So if you have coax run to whatever it is you're trying to get to in a nursing home or in any multi-dwelling unit, you don't have to run fiber or Ethernet, or so it's become a popular solution, especially in the hospitality side, right? RV parks, there's 17,000, 19,000 in the United States. And they a lot of times have cable infrastructure as well, and so they'll take advantage of that and put up little Wi-Fi towers. We have a Wi-Fi solution where you can walk around with a computer, like you walk to the pool and your computer continues to stay on the same Wi-Fi connection. It's pretty cool. It's kind of like the Wi-Fi 6 stuff, but it's part
Okay,
of that.
nice. Like the mesh system stuff.
Exactly. It's very
Yeah.
much a just it works just like a mesh.
Okay.
But yeah, so you can take your computer around and it continues to work, and it works through pedestals.
Okay.
So they have little Wi-Fi pedestals, and basically everybody on the park is on the same.
Nice. There was a period in my life where I wanted to buy an RV park as an investment property. I don't remember what
That's
happened, but it disappeared from my dream. But it's not a bad route to go.
Oh, it's very popular. Yeah.
Yeah.
That's why I think that's one of the reasons why we have 17 to 19,000. It's pretty easy to run. You can get people to run it pretty easily for you, and
Hmm.
it's a great investment for sure.
Yeah, that makes sense. I lived in an RV for uh, two or 3 years, but I mostly boondocked because I didn't want to actually
Mm.
pay to stay at parks and do that. I was too cheap. I was
If you
boondocking
did
before remote work was cool after COVID.
so if you did stay apart at a park, how was your internet? It probably wasn't very good, right?
I usually just would hotspot off my mobile.
Would you? Okay.
Yeah.
Yeah. We're trying to improve that situation. So imagine if you had, home style networking while you were
Hmm.
out RV, in an RV, you could stream video, do whatever, right?
I wish Starlink was a thing when I was doing it. That would have been a game changer for me because I had like the crappy, I forget what they were called, like the cell phone boosters that
Mhm.
kind of work, but they don't really work. I would
Familiar, yeah.
always like have because I'd be in places where I'd have like one bar, and then sometimes I could get my booster to work, but I feel like it um hallucinated and just made my phone think it had a better signal than it actually did.
Yeah, you don't actually pass any traffic at all. Yeah,
Yeah, yeah, exactly.
yeah.
So that was the struggle. But for the most part, I worked as a remote developer without issue. From time to time, I would get on public Wi-Fi if I really needed to move a lot of data, but it worked for being. I was an iOS developer at the time, and it worked. So
Mhm.
it was cool.
Yeah,
How
worked well enough to.
how do you think like Starlink and like satellite internet will affect your business?
I think we may use Starlink for backhaul a lot of times,
Okay.
because the parks have to have a backhaul connection of some kind. A lot of times we do fiber for that, but yeah, I mean, I think Starlink for backhaul, and there may come a time where everyone has Starlink, and our services aren't as valuable, but I don't see that in the near future. It'll be a while before it
Yeah.
sort of takes over. Yeah,
I think we got some runway there. I think like we'll probably see it transform in like our cellular networks and cell phones first. And
yeah.
then when those stop being a thing and it's all satellites, things will start shifting.
Yeah, I think probably when you can, if you have Starlink in your cell phone and you can tether, that's going to change the game for us. I think probably our services will be less needed at that point.
Yeah. Well, you still might, I feel like people will still need like network health and other services. You just will have to like shift a little.
Yeah, yeah, exactly.
Yeah. Like I think like that's like the whole fear mongering, but behind LLMs right now, right? Everyone thinks our jobs are going to go to the wayside, and I just like we were talking a little bit before we started. I think we're just going to not be writing code anymore. We're going to be orchestrating code workers and agents and reading it all.
Yeah, and I've mentioned this to you before. One of the nice things about being into physical networking is you don't have to worry about AI taking that, right?
Yeah, that's true.
Yeah.
Until there's robots that can do it all.
Robots and Starlink, right? They're gonna
Yeah.
take all of our jobs.
I mean, I would love, well, actually, I don't know if I would love this because I don't like all the, what do you call the Amazon boxes the Siri boxes that you talk to. I forget. I don't know why I'm blanking on it right now.
Oh, yeah, like the home. I don't know what they're called.
I don't know
Yeah,
what they're
but I know
called.
what you're talking about. Yeah.
But I refuse to have those in my house. And I was just about to say,
Oh,
I
really?
can't wait to have like a robot servant that will clean my house and cook for me. And then I'm like,
Hmm.
wait, would I actually want one in my house?
Would you talk to it, right? Would you trust it?
Yeah.
Yep,
Yeah.
I get it. I get it.
Yeah. So I don't know if I'd use it, but part of me thinks it would be nice to have a little robot servant
Mm.
until AGI and it turns into a Terminator situation.
Yeah. Yeah, and I think,
Jim Clark said Echo Dot. That yeah, but what are those systems called? Like they got to be called something, right? Because doesn't
I'm
Apple
sure
have
there's a
one too?
name, like a home assistant, maybe.
Yeah,
I
maybe.
don't
I
know.
don't know. Freaks me out
Yeah.
though. Won't do it. It's always
Listens to
listening.
everything you say. Yep,
Yeah.
listens to everything you say.
I mean, I guess so. So does this, but
It really does. Yeah. Yeah, I'll get a
but
few
sometimes
ads.
I take it for my advantage. Like I'll talk about something because I want the ad to show up on like Instagram because I can't find it again, and then it will. It shows up.
Oh, yeah. Yeah, it's a little scary. Actually, it's a lot scary.
It's actually really scary. I I tend to be like a little more paranoid, I think, with my security and like privacy. But then there's also I don't put in the effort. Like I know the effort required to actually have privacy, and I just don't have the patience.
Well, it's everything now, right? I mean, everything wants to listen, so it's
I
it's
know.
hard.
Everything wants our data. Our data. Yeah. Um oh yeah, I wanted to ask. So you mentioned that you are probably one of the like the biggest noobs in the Elixir space, and
About 2 years.
you've been writing Elixir for 2 years.
Yeah.
What brought Elixir on your radar?
So originally, so I used to be the host of the Atlanta Ruby users group before Rails, right?
Okay.
So I know I'm one of those Rails people who came to Elixir, just like most. But yeah, so I was the host of the Atlanta Ruby users group before Rails. And Obi Fernandez, I don't know how to say his name, but the Rails Way guy came up
Okay.
from Jacksonville and presented Rails 1.0. So I've been around the Ruby community for a long time, and I use JRuby to do a lot of concurrency stuff. And I actually wrote basically Gen Stage for JRuby back in the day, and came up with the idea of message passing instead of semaphores and all of that stuff, right? Which it seems like lots of people have independently come to that conclusion, right? Message passing is so much better than all the
As
other
of recently, too, they're just trying to
yeah. Well,
reinvent the
this
beam.
was this was 18 years ago. So, but yeah, so I wrote Gen Stage 18 years ago and just relied completely on message passing um, with JRuby. And when I saw Elixir, I was like, you know what? They solved all the problems that I felt like I solved with. It's a library called Common Thread, and they solved all the problems that I had back then. Before I
Yeah.
just didn't know about it.
Yeah.
Right? Erlang was around. Elixir wasn't around, but Erlang was around, and it's just a treasure. I think
It
I
is.
really I really value the Elixir community and all of the technical decisions that were made to get us to this point. It's
Yeah.
really a strong piece of software.
It is. I'm thankful for really smart people like, the Joses and the Chris McCords and all of that. I'm only a user of great technology. I don't think I'll ever be on the leading edge of something great like that, but I appreciate it. And I get to talk to them because I decided to start a podcast.
Which is great. Yeah.
Yeah.
Yeah, it's extremely helpful. I've been watching the podcast, again, just 2 years, right? And so I've just really immersed myself in the community, watched all the podcasts, and really appreciated them. So,
I
yeah,
mean,
I really appreciate the work that you put in to mentor everyone.
I always love to hear that because yeah, I don't know. It's I talk about this all the time, like that imposter syndrome. It never goes away. You just like
Mhm.
keep faking it, and then eventually it'll work out, right?
Yeah, it's so I value Elixir so much that I tell people, I've learned about 17 languages over my lifetime. I've been doing this since I was 8. Elixir is my 17th and final language. I think I'm done. It's
I
really great.
I wonder how many I've learned. Let's see, like Java, C sharp, a little bit of C++, JavaScript. Does TypeScript count, or are
I
JavaScript and
think so.
TypeScript the
I think
same
so.
thing?
Yeah, I
And
think so.
then uh, Kotlin, Swift, Objective C, which I hated Objective C. Uh, it's about like my ninth language, and I also want it to be my last. And then I haven't really taken the time. I kind of want to, but I want to learn like more Erlang, just because like there's so much more under the hood that we have access to, and we don't really take advantage of it. Do you
Yeah,
find
so
yourself using it more with like the telemetry and all that?
not so I have an interesting Erlang story. So I went one of the libraries that I've published is SNMPKit, which is a SNMP library, um, which is simple network management protocol. If you're not familiar, it's basically ancient at this point, but I felt like it was sort of a miss in the community. And I had some ideas around what I wanted to publish for a SNMP library. And so I went to the Erlang code and went through, there's some SNMP built into Erlang. And I was like, you know what? Uh, All it's really doing is just compiling down to, Erlang Beam machine code, right? And so if I just write this in Elixir, it'll be easier to maintain. And so I basically just abandoned the idea of writing wrappers around the Erlang, and just wrote it in Elixir. And I felt like I got at equal or better performance. And
Hmm.
so it was an interesting experiment, reading that much Erlang code. But yeah, I even have a mib compiler and all of the interesting side effects of having to do SNMP. But yeah, it was interesting reading Erlang. I have always been a syntax light guy. I learned Rex in college, and hold on one second. I'm sorry. I learned Rex in college, and I really loved it. And then I started working in networking labs, and I did TCL, which was very syntax light as well,
Hmm.
which is why I gravitated toward Ruby and eventually Elixir. So I like Erlang. I think it's fine. I think it's great for those people who enjoy it. But I really like syntax light languages like Elixir.
Yeah, I feel like that's like probably why Erlang didn't pick up in popularity too.
A lot of boilerplate. Yeah, there's a
Yeah,
lot of structure to your code, right?
right. And then I don't know, Elixir is just nice. It just
It flows.
flows. Yeah.
Yeah.
Yeah. All right. I'm going to put this on hold for a second and we'll be
Sure.
right back.
Hey, I'm Kimberly with Elixir Mentor. Jacob recently added recruitment services to help companies hire pre-vetted Elixir devs. I help with company outreach, so if you're hiring, I may be reaching out, or you can connect with us anytime at elixirmentor.com.
All right. And we're back. So what is what's the next thing? What are you most excited about with like your telecom business and using Elixir? Like what are you building next? Do you have any plans?
Well, for me personally, I get to, maybe get down to one job, which would be awesome instead of two. Um, and I think I would like to probably do additional work on the server side of Timeless. The embedded was what I focused on for this because I thought it would
Hmm.
be the biggest benefit to the community. And so I think that, 80% of apps could just drop this in and have full observability without any overhead. And I feel like that, most apps tend to be relatively small, right? They don't get 200,000 hits a second or anything
Right.
like that. And so if I can help those people first, that's my intention. And then, you can also sample like traces and stuff like that when you have the bigger apps and send them up to a central server. And so I'm going to spend some more time on the server, making sure it continues to be performant. So there's going to be there's a number of components, right? There's 3 different databases, and then there's Timeless Phoenix, which is the embedded, and then there's going to be a Timeless Stack, which is basically all 3 databases in one as a server component that you can push your metrics to centrally if you have multiple app servers, for instance. And so that's going to be next. I'm going to spend a lot more time on that. And as far as libraries that I'm interested in writing, I don't know. The telecom business is taking a lot of time, and so I don't know if open source contributions are going to be a thing. But everything that I've done so far, as far as evaluating compression libraries, making a faster web server, all of those things I've sort of peeled off and made open source. And so I'll continue to do that. If I find another compression technology that works really well for, say, logs, then I'll wrap that and then make it available to the community. But I don't have anything right now that's just off the top of my head that I would like to do, except just maybe continue with the timeless thing, right? And just make it better.
Yeah, when you're using timeless like server side, is it at all possible to make like a hosted service for it, or would it always have to be kind of directly tied in to?
It could be. And the
Okay.
nice thing about this, remember, you're compressing at the edge, right? And so when you're sending those logs up, if you're like, just as a perfect example, nerves, right? A lot of those nerves links are limited in bandwidth, right? They're using cellular or something like that. And so if we can compress at the edge and then send the packets up, it would be great to have a cloud service provider that understands those already compressed packets, right? And then could give you a single pane of glass for observability and a dashboard, Grafana or whatever. I actually have an interesting dashboard that I've built that's based on Scotty Toolkit, which is 30 years old. But it's fun. Like it's got a timeline at the bottom. You can put your logs and everything on your screen. And then you can track it over time, but you can there's a timeline at the bottom. You can grab it and go back in time, and it'll show you the logs from that time. It'll show you the traces from that time, and it'll show you the graphs from that time. So when you're troubleshooting a problem, like if you had a problem, say at 11 p.m. last night, you could actually just go back to that timeline, and you can see all the traces from that time, the logs
Oh,
from
that's
that time.
cool. I like
Yeah,
that.
it's an interesting idea. I don't think anybody's ever tried it before. The polish is not there. It doesn't look as good as your typical dashboards do today, because it is based on 30-year-old technology.
But now you
But
got Claude to help you clean it up.
I do. Well, and yeah, there's some UI cleanup that definitely needs to happen, but that'll be on the server side, and it'll be optional because everything has an HTTP endpoint, just like Victoria Metrics or
Okay.
Prometheus or any of those things. So you can actually just point Grafana at it if you want to just use Grafana, and
Okay.
you can create all your dashboards. You can look at your traces. You can look at your logs, and so you'd be able to, if you had a farm of web servers, you could just push all your metrics up to that. But I also really like the idea of compressing at the edge, right? So you just embed this in all your apps. It pushes the metrics up, and then you get a single pane of glass.
Yeah, I
So
like that. That would be cool.
I don't know which way I'm going yet,
I think
but
you got to build a
it's going to be
service,
fun.
a
I think
hosted
I got to build.
service. I think
A
that'd be
hosted
really
service
cool.
could be. It could be a thing.
Yeah.
We'll see how people like it on this podcast, and I might pursue that.
Yeah, I'll make
But
sure to
yeah.
I'll link your GitHub and whatever open source links. Make sure you send them to me, and I'll make sure they're up there.
Also, and I wanted to announce this on this podcast, so nothing has been published yet,
Ooh,
except to GitHub. If you follow my GitHub,
announcements.
yeah. So this timeless is going to be available to everyone. I'm going to put it on Hex this afternoon, and you can try it in your app. And I'll have a little. Jacob's already seen this, but a little snippet, a little 6-minute video of how to install it. What it gives you. And it's very short. It's very simple to use this. It was made to be simple.
That's
A
awesome.
lot simpler than trying to wire up your own observability. I assure you. But yeah, and I'll make all that stuff public today.
That's exciting. Ooh, I like
Yeah.
that. So make sure you get me the hex link and I'll put it in the show notes.
Okay.
Because yeah, that'll be awesome. I'm excited to check it out. I might have to give it a little test spin for kill switch.
Now so one thing that you probably should keep in mind is normally the dashboard isn't included in prod. It's only sort of a dev thing. So you can actually authenticate or create a auth for your dashboard. So you can wire it up so that your dashboard does get to push to prod, right? And then you can put auth in front of it, and there's instructions in the repository for that.
Perfect.
So that you can actually sort of you can in prod you can get all the metrics that you would get in dev and help you troubleshoot problems, which would be pretty amazing.
That is nice. Yeah, that's how I have my I use Air Tracker on kill switch, and then like my Oban dashboard. Always put that stuff behind auth, guys.
Oh yeah.
But yeah. Yeah, that's cool. I'm excited. I think I'm excited to hear about your new business. You said you wanted to get down to one business, but now it sounds like you're going to be starting another one anyways.
Yeah, I'll eventually stop being a DBA, and then I'll go do the CTO thing full time. I'm hopefully buy out the CEO and actually become a CEO.
But then you're going to start this timeless service, and that's going to be another product and business.
If people find value in it, I will be happy to provide it at a very reasonable cost, for sure.
Because I just think
remember, the compression's really, really, really good, and so I don't have to store much data. I just have to present it, right?
Yeah, that's because I feel like there is something nice when you don't want to self-host. Like there's a time frame in every startup where you just don't have time or the resources to self-host everything. And it's kind of nice when you can just reach out to services that are super easy to integrate.
Yeah, I agree with that.
Yeah. But then there's a point to where like, I feel like there's growing pains, right? You get to a certain point and then you want to self-host and control everything.
And I think, where I see this landing for most people is that 80% of people who develop a small app, they want observability. It's hard to wire up. You don't necessarily have a provider, and you run one command, one igniter, and you get full observability for your
really
app.
Cool.
And it doesn't take up much storage because we compress really well, and we roll the data off for you. So that, you get your 7 days of time window or whatever you dictate, right? 30 days, 7 days, whatever you want. But we roll the data off for you. And so it's basically self-managing. You just turn it on. That's kind of great.
That's awesome. Does it just, is it Postgres, or what are you?
No. So, let's talk architecture. Sorry, I haven't even really covered that.
Well, we have plenty of time, so this is good.
Okay. So the architecture we'll start with metrics. That's the easy one, or the more complex one, depending on how you look at it. But metrics, the metrics come in via either HTTP, or you can push them directly from Elixir. And so you don't necessarily need an endpoint because it's integrated into your app. But the metrics come in, and then we push them to Rust, which indexes them. So it keeps track of the tags, and then the data itself, it all gets compressed. We compress. There's 16 bytes of data per metric. We compress it down to just over 1 byte, which is fantastic.
Yeah, that's awesome.
And it's all searchable. There's a nice index. We do use SQLite for some things. It's because it's embedded, right? We have the ability to alert you. And those alerts have to be stored somewhere when you set them up. And so those alerts are stored in SQLite. There's a couple other things I'm trying to remember exactly. But yeah, we do have a SQLite database.
Okay. Do you use ETS tables at all or anything like that?
Not as much. That was in every possible, I've been working on this for 2 years, so I've re-architected it about 15 times. 14 times, yes, lots of vets. The 15th time, I went to Rust, and so it basically just hands the data off to Rust, and it keeps
Okay,
track of the indexing and does all the things.
I see.
But yeah, and then logs and traces. There is a SQLite database for those, but we just compress the values. We keep an index so that you can search. Right, the search is very fast too, by the way. And so if you wanted to go find, all of the traces for the guy who, or for get, slash this URL, you could just go and pull those traces, and then you can click on it and you can look at the trace, just like any other
Okay,
observability
yep.
application. It's very simple. We kept it simple for a reason, but it's quite searchable, and it's
I
very
feel like
fast.
it's a good example for SQLite as well, because you just are passing, or you just have a JSON file living in the project at that point, and you don't have to worry about a Postgres database being there or an instance of something larger, right? It just kind of
Yep.
works. Yeah.
Yeah, I even played with storing the traces and everything, compressing them down, storing them as blobs inside SQLite. And that worked okay. It was fine. But block store is much faster.
Okay. Interesting.
Yeah.
I feel like I'm pushing my skill level, my technical skill level, especially like when you come down, just performance in general is a very hard thing to like really dig into, right? And like when you're picking between like SQLite or maybe a MySQL database or an ETS table, like what made you lean towards SQLite over using like an ETS table?
Well, I had this idea from the very beginning that I wanted to have an embedded version of this. It may not
And
be the final end all be all, but there was going to be an embedded version, right?
yeah,
And so SQLite's just much
is
easier
there
to
a
embed.
limitation with ETS or ETS on embedded hardware? No. Okay.
No, it's just the persistence isn't there, right?
I see.
So
Oh, right. Like if you lose your
yeah.
instance, everything's gone.
Yeah,
Yeah.
now you can have it. Obviously, you can take your ads tables and dump them to debts, and you can do, or
Mm-hmm.
dump them to SQLite for persistence. Right?
Mm-hmm.
You can do like a slow path for that. You could push it to ETS very quickly, and then have a process that kicks off and sends it over to SQLite for persistence. I've done all of those things. I've tried 15 different versions of every one of these three servers. But yeah, I've settled on what I think is probably the least amount of overhead for an
Yeah.
embedded app.
Okay.
So I've always had that embedded in my head from the very beginning.
And those are the important decisions. Like those architectural decisions are not easy ones. And see, like that, guys, is where we're not getting replaced by LLMs. You know what I mean?
Yeah.
Like you would not get your architecture choices. Like if we put this into Claude right now, we'd probably get some. I'm sure we'd get like a working plan that would probably be functional, but it probably wouldn't perform the same way.
I will say though, I've worked in tech for a long time, and I've worked and worked with a lot of really intelligent people. And I learned a long time ago to ask open-ended questions. Just go and say, I'm looking to do this, and then have it come back with some possible solutions. And
Mm-hmm.
maybe they're good, maybe they're not. But and then maybe they apply and maybe they don't. But if you ask the open-ended question, they may think of something that you have not thought of, which is,
Mm-hmm.
and the LLMs will do that too. So if you ask open-ended questions of LLMs, they can help guide you. And
I think it's a
it's
great way to like rubber
valuable.
duck, like especially for a lot of developers that are remote. Like we get in our own little echo chamber or echo chamber, and it's nice to talk to a robot from time to time about your ideas. I mean,
Well,
I
and they're
learned,
encyclopedias. It's
yeah,
why wouldn't you ask an encyclopedia what all the options are? Why wouldn't you go there and do that? They may not have the best option for you, and it may not bubble up, but as long as they know all of the options, it's more than you,
yeah.
right? And so they can help you.
And like when I did Kill Switch, which, it's like a zero knowledge encryption document store, right? I didn't really know how to implement a zero knowledge encryption system well, right? Like I've read my encryption algorithm books and things like that, but they don't actually, like, I know how they work at the encryption level, but like how do you properly implement it? And dude, I'd like open-ended questions and rubber ducking with Claude back and forth how I wanted the system to work client side. Freaking helped me iron things out so much faster than I would have by myself. I think I would have still got to the same solution, but it would have taken me a lot longer.
Yeah, I
Yeah.
agree with that. It's, it's just nice. I mean, just having something that knows more than, no matter what, they know more than you do, right? They have more scenarios in their heads
Hmm.
than you do. You've been down this path, and so you have your predefined things that you would like to accomplish. So you have to obviously measure it against that. But yeah, it's great. It really is great. It's helped quite a bit on Timeless for sure.
Yeah, I'm sure. That's cool. What does your like day-to-day workflow look like using, like, do you use Claude or what LLM do you prefer?
Oh, sure. So in the car, in the car, I use Grok. I'll
Okay.
just start it up and I'll start having a conversation about how I would like to compress things or how I would like to index things, right? And Claude, sometimes I'll take those ideas and bounce them off of him once they're sort of formed. And then still trying to ask open-ended questions if at all possible. And then for cleanup, I've found GPT to be really good. So Claude, you can have it. It's very innovative when it writes code, but it doesn't necessarily get it right.
Mm,
So I like the innovation sometimes. And so when I'm trying to innovate, I'll use Claude and then I'll come back with GPT and sort of clean it up and make sure that it's doing the right things. But that's my work. Excuse me, that's my workflow.
okay. Nice. When you're like thinking through a feature, what does that look like? Are you chatting back and forth with Claude and creating like a markdown plan, or what's it, what are you doing?
So yeah, so previous versions of timeless metrics used ETS quite heavily. Um, and I was hitting performance bottlenecks. I was trying to hit numbers that approached the Go space, the Victoria metric space, and I was unable to do so. I got really close, and I eventually got faster, but I had to get away from ETS, unfortunately, and so I used oh, what's it called, persistent terms, and that made it a good bit faster.
Okay.
Um, and then yeah, and then eventually I just kept breaking off pieces and making them NIFs, and then of course those NIFs would have to talk through Elixir, right? And so that became a bottleneck too. And then I just basically bundled it all together. But yeah,
Oh,
it's
interesting. Like having too many NIFs was a bottleneck, but having like one
yeah, I was
access point
passing the
is
data
better.
through Elixir, yeah, from one NIF to the other.
Okay.
And so
Oh, I
yeah,
see.
you just take
Yeah.
the two NIFs and just put them into one, right?
Yeah, yeah.
Um, and so it's easier for it to Rust to talk to Rust.
Right, that
It's
makes
faster.
sense. You had
Yeah.
just a middleman that was slowing things down.
Mhm. And it's still, again, Elixir, fantastic, best there is as far as
Hmm.
orchestration layers is concerned. I wouldn't trade it for anything for that layer of it, even if it does cost a little bit in performance.
Yeah.
And 3 million inserts per second that's a lot. Back in the day, I told you I wrote this application for monitoring cable modems for Cox back in the day,
Hmm.
and I was just completely ecstatic to get 10,000 inserts per second back, with those little pizza boxes, the single core pizza boxes. um, and now we're doing 3 million inserts per second, which is crazy, and compressing it, right?
Yeah, no, that's wild. Like it's actually hard to kind of wrap your head around how much data that is.
Yeah. Yeah, well, it's more than most people will need, but it's also necessary, right, to keep that overhead very low, right?
Hmm.
So if you want to put this in your running application, you want it to not affect the running application. You want
Right.
to be able to throw as many logs as you want to at it without affecting the running application. And
Hmm.
so I felt like performance was absolutely paramount, and I was able to achieve everything that I basically set out to do.
Yeah, that's cool. I'm not like very familiar with Rust or using NIFs. What was your learning curve there? How did you?
Huge,
Yeah.
huge. I had not done it before either, and it was required, I think, for the performance that I was looking for, and so I just head down, figured it out, asked a bunch of questions of the LLMs, right, to help me understand. The trans and your Rustler is just fantastic. It does take care of, and I use Fine too. Fine is used, I think, on the Rocket side. I do have a couple of different interfaces, but yeah, it's not as hard as you think, but it's a learning curve for sure.
Yeah. I heard like handling like errors and like hard crashes is difficult to like get back out to the Elixir layer to actually be like helpful.
That was a big part of it. You have to actually you sort of write Rust the way you would Elixir, right? You send errors back.
Mm-hmm.
So yeah, if anything breaks, you send an error back, and so that Elixir can understand what broke, right?
Yeah, yeah.
You try to behave like an Elixir application
I
at that
see.
layer,
Because
and you
it's
send
really
those
easy to
errors
just
back up.
swallow
Mhm.
swallow the errors, right? When you're like
or
creating
or
NIFs and things.
crash. Yeah, you
Yeah,
really don't
yeah.
want to crash either.
Right.
So yeah, that's going to be one of the interesting things about making this public is people are going to use it in ways that I have not. And so there may be some crashes out there. We'll get it all worked out. Try to treat it as at least beta level software. Probably not alpha. Probably beta
Yeah.
level software. But yeah, be careful because
Is
we are
this
dealing with a lot of NIFs.
your first like open source project that you're taking public?
No, I've maintained something called SNMP
Oh
4J
yeah, you
R.
said that. Yeah.
Yeah. So I had an SNMP library that I open sourced. It was kind of a wrapper around SNMP 4J, and it's
Okay.
for JRuby. Uh, 18 years now, I guess. But I
Okay.
haven't had a lot of open source projects. I've really embraced the Elixir community, and I want to say 10 now. But I
Oh
have,
wow. Okay.
yeah, quite a few things that I've released on the Elixir side. I have a SOAP library because we needed SOAP. We're a telephony provider, and telephony providers love SOAP. So I have a SOAP library that is free for all, and it's actually I think it's the most popular library that I've released on Elixir ecosystem.
Oh, that's
The
cool.
SNMPKit is very popular as well. I wouldn't say very popular, but it's more popular than I was expecting. And then all these compression libraries that I've been wrapping, all the little NIF accesses. Um, you know, I may not be using them anymore, but I have released those as open source, so you could use them
Okay.
if you wanted to. Things
Awesome.
like not Z standard, OpenZL. Uh, Trying to think,
You're making me
uh,
look bad. I have no open
ALP.
source projects and
Really,
yeah,
you
none.
should think. Just peel off little pieces. Like as you're
Yeah.
working, just think, hey, this little piece right here, I think could probably be useful to someone else, and then just peel it off. And there's some packaging that's required,
Right.
right? It
Yeah.
takes a little bit of work, but with LLMs, right, the packaging becomes a lot easier.
Mm-hmm.
And so I've just peeled them off and just made them available to the community. So it's relatively easy to do.
Yeah. No, I think it's awesome too. Like I wish I was a better person, you know?
Well,
But
there's some sort of encryption you're using, right? Is there a way
yeah,
to peel off the encryption and maybe release it? Yeah.
I'll
See.
have to think about that. The problem is like all the client side stuff is done in JavaScript. And
Oh, okay.
so, but I don't know. There's probably a way I could do it. I'll have to think about it because for any backend encryption, I'm just using Ash Cloak for that. And dude, I love using Ash for my production stuff now because it's just so fast. I don't know if you've used Ash at all, but
Wow. So that's a part of the conversation I haven't really gotten into. So, the provisioning side of DOCSIS, the cable modem stuff, that entire stack is Elixir now. We've got
okay,
a DHCP server that's commercial quality, right? A TFTP server that is commercial quality. We have an NTP server that is Stratum 2 compliant, which is pretty cool. That's sort of telephony level NTP. We have. I'm trying to think of what else. DOCSIS boot file editor, which doesn't mean anything to anybody on this call, but yeah, a number of things that help us do the provisioning for cable modems. That's all Elixir. That's a full Elixir stack.
Okay, cool.
Yeah.
Yeah, but so I started using Ash, and it was a hard learning curve for me because it's like another language. It's not Elixir. It's, their own DSL thing. But what's nice is like for production stuff, like what your schemas look like and all of that, and it takes away the overhead of writing an ecto schema and then fine tuning your database migrations. Like it does that all, just like the way you set up your relationships and resources. It's amazing. I don't know. I suggest checking it out.
Yeah, it reminds me a little bit of Rails. It helps you sort of translate your business logic very easily into your schema.
Yeah, yes.
And that's what we've done on the DOCSIS services side is we've used Ash. I forgot to mention that. The reason why I told you all those things is because we did use Ash for that. And yes, it's fantastic to just apply your business logic to what you're doing on the database side.
Just write your resources, your relationships, and actions essentially, and then you have your schema and context files basically all in one small module. It's really nice.
Yep. Yeah, we really like it.
Yeah, and I struggled with it though until the Ash book got released. Because I just needed, I don't know, I needed to read it and see how it was being built. Like I looked at tons of examples in the documentation and I was just like, I always struggled with like, okay, I know how to do this in Elixir and Phoenix. And I know the Ash way is like a one-liner in a config somewhere, but I don't know how to do it. So it's just like, it turned into just being frustrating. But then once you unlock that, the syntax and how to use their DSL, it's just, you move quick.
We had difficulty when we first started the apps with Ash. The LLMs didn't know it very well.
No,
I had trouble with Claude and that has improved dramatically in the last couple of years. So yeah,
when they released usage rules, it helped a lot because you didn't have to write your own Ash. Like you didn't have to add to your own like MD file,
Right. Yep. Yeah, that's it was painful. Unfortunately, using Ash back in the day, this was 2 years ago. But yeah, I've done a couple of things recently and it's been so much better. It's much better now.
I agree. But yeah, game changer. I don't even know if I can write normal Elixir code. I was going to say, I don't know if I can anymore, but I write it every day. The day job keeps me current with, Ecto and Elixir and Phoenix. And then all my side projects are now Ash.
I will say it's much nicer not to have to shove the bits around. Like I can really envision what I'm trying to do, and really get down to exactly how I want it to execute. And I don't have to write, all the little bits and pieces and, accidentally type something wrong. Like, it's just, I find it as very liberating. It accelerates me for sure.
Yeah, I agree. Well, like one thing that I think is the superpower is just like, I always look at my database migration files when they're generated, but I've never had to alter them or add an index or anything with Ash. Like it always is right.
Very intelligent. Yeah.
Yeah. So that's nice. Cause I feel like that's the missing link. A lot of people like lately I've been reviewing so much. I shouldn't be mean on my podcast, but a lot of AI driven projects that are just kind of like over-engineered slop. And you can tell that an AI generated it. It's like, sure, it's good code. It works, but it's like, it's too much. Like, I know you didn't put any thought into this. You let Claude engineer the whole solution. And that's been getting old. But one thing Claude sucks at is database performance.
Yeah.
So it'll miss indexes in the migration files. It'll do all that. And like, that's a great, like if you're getting interviewed, guys, a great got you is like, okay, what happens if I need to query 500,000 records off this. Like, is it going to perform or is it going to time out?
Yeah, as a DBA, I fully support this message. Yeah,
Yeah.
check your LLMs and make sure that they're doing the right things.
Yeah.
So yeah.
And honestly, I took for granted because like we were talking about before, like the average software business, you have a couple thousand users, right? Like you're never going to hit performance hurdles or cliffs just because you can kind of just write sloppy code and get away with it because it's just going to
Yep.
work. You don't have enough data. But then when I started working at Collex, I had to start learning about, I had to be mindful about, where you place indexes, how you're using them, and how you're doing table joins and all these things. Because I, like, the very first feature I released, I like crashed production and it was very stressful, but I had to go in and fix it. And I learned all about taking a deeper look at what was my MySQL query, what did it look like, and was it what I expected? And it wasn't, because we use AppSynth, which is like GraphQL, and a
Mhm.
lot, like for the most part, it generates your queries properly, but sometimes it doesn't, and you have to kind of force it to build the query you want.
Yeah, I work with my day job. I work with 60 different dev groups, and they have all different flavors of ORMs, and we have issues like the GraphQL issues all the time.
Yeah.
Actually, after I finish this call, I have a call with someone who has a oops, I have a 600 million row table. How can you help me clean it up? So it's the life of a DBA.
uh, do you I'm like, how do you handle that? Do you back up the table before you start messing with things and then?
We figure out what they want to keep, and then we have some online schema change utilities that Facebook published a long time ago that we've modified. Facebook, they do a couple of passes. We do three. So we'll take this very large table, we'll copy the data out that we want to keep, and then and that can take a while, right? Because sometimes you want to keep quite a bit. And then we do a delta, and then we copy the delta over, and then we lock the table. We copy the last little bit, and then we swap the tables.
Okay. All right. So you never officially drop the table you're fixing until you confirm that everything's good.
It depends.
Oh,
Sometimes it's just a queue, right? And they don't care.
that sounds like
Sometimes
some Wild
it's
West
business
shit,
data.
honestly.
There's you'd be surprised. It's a lot of different dev groups, and some of them
Yeah.
have are focused on the size of their data, and some are not.
Yeah. 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 Touching a prod database always makes me nervous. I'll always aim for the replica first, guys.
You should try it as a full-time job. It's exciting.
I don't know. I mean, honestly, I'm sure it's probably a lot of fun, but it seems like a lot of responsibility.
It is. You just have to be careful,
Yeah.
and it comes with time.
Yeah. I don't know if you actually answered this at the beginning, but what got you into the database space? Like, how'd you become a consultant for that?
So I built this really large data warehouse on MySQL of all things. Back in the day, it was a Snowflake database before Snowflake was a thing. Snowflake's an actual design of a database, not a vendor.
We use
But
Snowflake IDs. I know that, but
okay.
and
Um,
basically because it was a bad architecture decision and we were running out of primary IDs.
Snowflake is basically you take your data, you have a set of raw data, right? And then you have derivative tables that are around the Snowflake, right?
Okay.
They're derivative intelligence that you've derived from the data. And then you take those derivative tables and you sort of join them together, and then you make Snowflake tables out at the edge, right? And so we did that with MySQL back in the day with what was at the time a very large database, 3 TB. Which is one of the reasons why I love observability so much, is because I built that database and we put so much data in it that it would take 3 weeks to do like a column add, right? With observability, with these new time series databases that we've come up with over time. Unfortunately, we didn't have them at the time, but it becomes a columnar format. You can very easily change the data that's flowing in. You can have new infrastructure that just automatically starts getting scraped or pulled or whatever, and it's really cool. I really find the concept of a time series database just completely fascinating, because I've been completely scared to touch any part of my database because it was so fixed. It would take 3 weeks to modify.
Well, that's
anything.
wild. Like
Yeah.
doing a column change or anything, if it takes 3 weeks and then it doesn't work the way you expect it to, then you got another 3 weeks to test a fix.
Yeah, it's a very it's not exactly what you'd call a tight iterations cycle.
Yeah.
Yeah. One oops costs you 3 weeks.
That's crazy.
Yeah.
It's an expensive 3 weeks.
It is. Yeah. Yeah. And that's, again, if you compress it down, right, your data gets smaller, and you make it columnar so that, you can easily change what data goes in, what data, doesn't, and it compresses it so nicely. I'm just very fond of it. And I've always kind of wanted to write one. And so it's been a really good experience for me to finally get to do that. I read the papers that came out for Gorilla when they first came out. Facebook published a paper on Gorilla probably 15 years ago, and I found it all very fascinating. And actually writing one finally has been it's very rewarding.
Yeah, that's cool. Oh, well, I mean, I feel like that's the only way to learn is to build it.
That's the primary reason. I didn't necessarily want to release it, but the performance was so good. Like, I had pretty high expectations for myself. I ended up with something that performs relatively well. We're at least, as fast as Victoria metrics, or probably
now you got the bragging rights. You have to release
the second
it,
fastest. Yeah, we're probably the second fastest database as far as ingestion and search.
That's
and
awesome.
everything.
That's very cool.
So yeah, not bad.
Guys, he's only been in the Elixir world for 2 years.
2 years, yeah.
He's blowing our pants off. He's making us look bad. That's awesome. That's so cool. And now it's going to be officially a hex package this afternoon.
Yes, this afternoon I should be able to publish the Timeless Phoenix. Go ahead.
How many years have you been writing this?
2. It was
okay.
I started.
Oh, so you started it as you learned Elixir?
Yeah.
Okay.
Yeah, pieces. Again, I read that Gorilla paper, back in the day. And so the first thing that I did was Gorilla. And of course, along the way, I decided Gorilla wasn't a good enough compression algorithm. So I threw away that code, but it did start 2 years ago when I started writing the Gorilla compression algorithm. And we use much better compression now. It's faster. It's better in every way than Gorilla. But it started with Gorilla.
Okay. That's cool. All right. What does your supervision tree and things look like? Like, how are you handling that side of things? Because we talk about how awesome Elixir is at orchestrating, but what does that mean, right?
That's a really good question, and something I kind of wanted to cover on this. The nice thing about having supervision trees means that you have layers of isolation for your application, and you can do things, right, that you wouldn't necessarily do with C or Go, right? So if you're developing a time series database in Go, you're going to do that in isolation. If you are developing a log database in Go, you're going to do that in isolation. If you're going to do that, for traces, you're going to do it in isolation. You're going to end up with 3 different services because you don't want one service crashing and taking down the entire thing, right? But with Elixir, it doesn't cost you anything, right? So you can just throw all those services in one, with the supervision tree. And then, if one of them goes down, it's just the one that goes down and it comes right back up, right?
Yeah.
We do that on the DHCP server. We do that on all of our services. We piled every one of the DOCSIS services into a single Elixir app. And we don't worry about one going down and taking down the entire app because it won't. Right. Supervision trees are amazing. We even have sort of advanced supervision trees on the DOCSIS app side where you can stop and start services. And it's all green threads, right? So the services immediately stop and they immediately start right back up, which is pretty cool to see. It's not
That's
like
cool.
running a binary, right?
So you're you're running like a dynamic supervision tree and then dynamic processes off of that as well.
Yep.
Yeah,
That's
cool.
exactly how it's done.
Yeah. Yeah. The actor model and like just the fault tolerance of Elixir. I guess I can't say of Elixir, of Beam VM is freaking magical, honestly.
I used to have so much respect. So I've worked in telco for a long time, right? So we had 5E switches. We didn't have Ericsson switches, but we did have 5E switches back in the day. And we had a ton of respect for those guys. The 5 nines, the 10, 6 9s or whatever of uptime that they were able to obtain. And they were always in the data center and they were sitting there by themselves, just doing their thing. But I always had tons of respect. I was a data engineer and they were the telephony guys, right?
Okay.
And it's nice actually working with the software that they were working with at the time, even though it's not the same, right? It's a 5E switch versus an Ericsson switch, but still, switch technology is phenomenal, and I think we should not take it for granted. It's really good stuff.
I mean, we take it for granted for sure.
Yeah.
But like we're able to do that because of how well it just works.
Just works.
Yeah.
It's fantastic.
Did you like when you were saying you said 6 to 10 nines?
Oh yeah,
of uptime. Like that's
there. I think there's an Ericsson switch that ran for decades, right?
Yeah,
there's like
probably
multiple decades of uptime. Yeah,
Yeah.
it's pretty crazy.
That's wild. What's crazy is like there's no hardware failure. That's even more
Well, they
impressive.
have redundant hardware.
Okay.
It's the way it's designed. It has redundant hardware. They can pull boards out if they go bad and put boards back in, and it's hot swappable. It comes right back
Okay.
up.
Yeah, that makes
So yeah,
sense.
it was really advanced stuff for the time.
Yeah.
And I that was the beginning of my career. So that was 30 years ago.
Yeah. Yeah, that's wild. They solved everything in the mid 80s, really. And then we just keep getting new problems that have the same pattern, which is cool.
Exactly.
Like, it's funny watching all the banter on like X with all the LLM companies of like, what's the best tech stack now for agents and all this. And I don't know, are you familiar with Mike Hostetler?
Oh yeah.
Yeah, he likes
Gino.
he likes to get in there and get all controversial. It's fun to watch. I sit back, I just like to I'll be the nice face of Elixir, and but it's fun to watch him poke the bear.
Yeah, and I agree with everything that he says. I think Elixir is a fantastic environment, especially for agents and stuff like that. But unfortunately, I'm on the performance side, right? So I had to do some NIFs, but yeah, I think the performance is a quarter of
Yeah.
what you get like in Go. That's still very, very good. That's 10 times faster than any interpreted language, right?
Yeah.
So it's the performance is good enough for just about anything you want to do, except for maybe build a database, right? But
Right. Well,
yeah,
I feel like
it's fantastic.
I feel like he would agree with you there, right? Like you're using Elixir for the orchestration and like the process capability, like spinning up thousands of processes like nothing, right? But you still
Scheduling
might,
things.
yeah, depending on what kind of data you're pounding through, you might need a NIF, you might need to use Rust, you might need to use something that's just more efficient at, heavy calculations and math.
And Elixir is a polyglot, right? You could write Lua, you could write Python, you could write Rust, you can write Zig, right?
Mhm.
Ziggler,
Yeah.
C++. It's whatever you want to do. You can pretty much do it in Elixir and just peel off the parts that need just a tiny bit more performance. You just peel that off and do a NIF, right?
Yeah. How did you go about like breaking down like what needed the performance boosts? Like how'd you find those problem spots and how'd you tackle those problems?
Most of them were obvious. When I started trying to, what you do when you ingest metric data is you have a set of tags for this particular piece of data, and then you have a value. And those tags, that lookup takes time, right?
Hmm.
That's the sort of the bulk of what takes time. And so, I first did it in ETS tables, then and just a lot of different. I tried everything, but yeah, we first did it in ETS, and that lookup would take time because it is such a kind of a long string, right?
Hmm.
And so it became obvious. It was. I don't want to say that I did some grand deep dive into the beam and figure out exactly what the performance issues were. I kind of knew,
You
right?
just saw your bottlenecks just with time,
Yeah.
like the
Yeah.
query length or whatever. I guess it would be a query.
Well,
Yeah. But
and I also have the ability. So someday, and this day is not today, but someday I'm going to have the ability to already know what your metric ID is going to be, right? So you have to derive that long string into an ID and then store the metric. And
mhm.
so if you just store the ID and the metric, I've gotten up to like 13 million inserts per second, right? So, if you just do that and you have something that collects the data that's intelligent enough, sorry, my dog's about to bark.
You're fine.
You have something that's intelligent enough to collect the data in such a way that it knows that that ID exists. You could actually insert it, 13 million inserts per second. But yeah, so it makes it obvious, right? If you can insert that at 13 million per second and you're only at 3 million per second if you have to do that lookup, your bottleneck's the lookup, right? It's
Right.
pretty easy to determine what your performance penalty is.
Yeah, that makes
And
sense.
so yeah. And so unfortunately it was easy. I wish I could give you some insight on, how to find performance issues in the beam, but for us, it was obvious.
Yeah. Well, if you always want to know if you want to know everyone's tricks, right? Like that's where you learn.
I don't
That's
have
where you
any
learn the
tricks.
juicy stuff.
Don't have any tricks, unfortunately.
How do you how are you like pushing your boundaries and how are you keeping those metrics? Like what kind of test system do you have to like know what
Oh,
your limits are?
so I did most of the development on a Air, right? A M4 Air.
Okay.
And so it was okay at sort of judging performance. I did upgrade to the M5 Pro with the maximum number of CPUs, but lower number of GPUs because I don't need GPU cores. So I could sort of test, with best of breed processors. I also have an AWS account, and so I did spin up a 192 core ARM instance and try this against Victoria metrics. And then I also did a 96 core against Victoria metrics, and we did well. We didn't actually beat them, but we did well. And I really feel strongly that we're probably the second fastest time series
The
database.
time will come to be number one. I believe in you.
Yeah, eventually maybe we'll get there. But yeah, it's the performance is pretty phenomenal, and you'll see it when you start to use your app, especially if it's you're not doing millions of inserts per second.
Hmm.
The query performance is phenomenal. It's way sub millisecond. It's like we're into like tens of microseconds.
That's wild.
Um,
I
yeah,
feel like running your benchmarks is like the hardest part because
it is.
your
When you
number
have to
like
do that, right?
yeah.
Every little thing that you change, you have to run all the benchmarks to make sure that you didn't affect it too much, right?
Mm.
And so, yeah, benchmarks become a big part of your life when you're doing database stuff.
Do you set up tests for like time benchmark, like speed benchmarks and things like that? Like, how do you know if like something you just tweaked actually effed everything up?
I probably should. They
Yeah.
probably should. But it's all manual.
Okay.
I'll finish a session and I'll run a benchmark and make sure that I didn't regress. I usually do it on a branch because I worry so much about performance regression.
Yeah. Yeah.
I'll do it on a branch. I'll make sure and test before I merge, so I know exactly. And sometimes you just take performance penalties, right? Sometimes it's just this was valuable enough that I'm going to take a 10% hit on my performance, but it makes it a more robust
How
service.
often has that
So
happened where you've had to take the performance hit for something
a
that,
few
yeah.
times, yeah,
Yeah.
a few times, yeah.
Because I feel
There's
like
especially on the Rust side,
your whole
yeah.
your whole thing though, like performance is so important. So
Mhm.
it's a hard decision, right?
It is. It's a hard decision, and again, it's made me it's made it easier on me just knowing that embedded is my goal, right?
Yeah.
At least initially. So if embedded is your goal, then performance, there's no way that any one of these apps, I mean, you could have a server that's 192 cores, taking 200,000 um, HTTP hits a second, and it still couldn't generate enough logs for you to cough, right? And
Mm-hmm.
so having that as your baseline, and shooting for performance numbers that are so high, um, it makes it easier, right? So you can say, well, I can take a 10% performance hit on this, and it still will be good enough for 99% of the users,
Yeah.
right? So
Yeah.
yeah.
Yeah, that's cool. I feel like, yeah, like your benchmarking was probably the hardest process to set up too.
And I did lots of different kinds of benchmarks. I would do like a sustain load on queries and a sustain load on inserts and see how they affected each other, right? Because usually with metrics databases, they're different, right? So usually with a normal database, which is what I deal with in my day job, you're 99, 95% reads, and 5% writes.
Mm-hmm.
Whereas this is 99, 95% writes, 5% reads. And so it's a very different way to look at databases, but I wanted the read performance to be very good. And so I really did focus on that, and kept the read performance really good too. So
That's good. Yeah, I could
yeah.
see that kind of being ignored because you'd be more willing to wait on getting data back to investigate issues than obviously writing data because you need all your logs. You can't miss any.
But I also still had that in the back of my head, right? I wanted that canvas, where you could drop your graphs on, right?
Mm,
All of the graphs that are they're relevant to whatever you're looking at, and grab that timeline and go back and have every one of those graphs repopulate as quickly as possible, right?
yeah, that's
So I
cool.
did have some
Yeah.
performance goals in mind for that, and I think everyone's, I love the canvas, but I don't know that it's going to be something that everyone embraces. But you always have Grafana. You can always go back to Grafana and do your normal, trace
Yeah.
lookup or your graphing or your dashboards or whatever. Um,
Yeah.
but uh, but I wanted it to perform. From a read perspective, I was really hoping for really good performance.
Yeah, that's cool. We just started using Grafana at the day job, so I'm like kind of learning it. It's not too complicated, but it's pretty cool with the amount of data you can have.
Yeah, it tends to be convoluted. Like it has a lot of little knobs and buttons and things, and I think that
Yeah.
that doesn't work well for a lot of people. I tried for something different,
Yeah.
and I've achieved it. Hopefully, I'll release the server component with the Canvas engine later, and
Okay.
it'll be hopefully people will like it. We'll see.
I think people will love it. I'm excited to get my hands on. I'm gonna put Timeless into Kill Switch today, this afternoon,
Oh, sweet!
and I'll give it a
That's
run.
awesome.
I'll play around with it.
Our first user.
I don't know. We got a couple people here just waiting for it.
Mm.
Let's see. Oh, Daniel said Elixir plus C equals conquer the world. Man, yeah,
Yeah.
C is that's a good heavy
Um,
lifter.
Yeah, there's a web server called Rocket that I developed specifically for this project so that I could get my latency down for HTTP requests.
Mm.
And it's all C, and
Oh,
it's great,
nice.
and it's
Yeah.
fast. Yeah, it's very fast. It's 30 times faster than Bandit
Wow. That's
from a
wild.
latency perspective, which
Yeah.
is latency is what I cared about. Yeah.
Right. But 30 times, that's a lot. That's a big number.
Well, and it's just the latency, right? So it's 3 times faster in requests per second or something like that, and depending on your pool size. But yeah, it's faster. Let's just say it's faster. And the latency was what I was concerned about because I wanted to be able to pull the data out as quickly as possible. And so I just bypassed, basically Bandit, any of the HTTP, the plug, right? All that stuff is bypassed. It just basically interprets your request, figures out what you wanted to do, and sends the data back as quickly as possible.
Mm-hmm.
And it's called Rocket. It's released separately as an open source project as well. But you have to know you need it, right? Because Bandit's extremely fast, right?
Right.
There's not a lot of people that need a lower latency than Bandit.
Yeah. Well, it's like you have to run into these limits before you know you need to fix them, right?
Yeah, I was doing benchmarking, and half of my benchmarking is internal metrics. Like I'll just push the metrics directly into the database. The other half is, hey, how am I going to do against things like Victoria Metrics and Prometheus and those guys? And they all have HTTP interfaces. And so I wanted it to be relatively fast. And so I thought it was an important part of the project.
Mm-hmm. So all these systems you're using basically like just a REST API for taking in data, or not necessarily?
There are well-established interfaces that I had to
Okay.
conform to in order for things like Grafana to work. And so I just followed those.
Okay.
There's nothing, yeah. And it's not REST, it's similar. But
Okay.
there's PromQL, I think is the one that I conform to the most. And so you have a certain way that you query and a way that you push data in.
I see.
And I had to follow those standards in order to work with Grafana and other.
That makes sense.
OpenTelemetry pushing metrics has a certain format that it wants to send, and so you don't have a lot of.
Would sockets ever be an option or not really?
Yeah, I mean it'll hold the HTTP connection open and just keep sending
okay.
data.
Yeah.
Mhm.
Gotcha. Okay.
It's like WebSockets, but it's not technically. It's just an HTTP connection.
I see. Got it. Okay. Excuse my slowness. I have to sometimes ask the dumb questions.
It's just like WebSockets, though. It holds the connection and just continues to send data or query, right?
Okay, cool. Yeah, that's awesome. Yeah, I think we can wrap this up. This has been a lot of fun. The time goes past so fast on these things. I don't know how it was for you, but yeah, me too. And it was great meeting you. Do you have any advice for developers that are just getting into Elixir, have been learning it a while, just anything,
Know your strengths. Know what Elixir's good at. Really take advantage of that. Don't necessarily pull off NIFs because you feel like you need to. I had very specific performance targets, and I felt like that was necessary for me. But Elixir's a very fast language. I think you're going to be fine. Ask open-ended questions to your LLM. I think that really helped me a lot. Understand what is out there as far as compression technologies, and then zero in on the ones that are most important for me. They have a lot of data. They don't necessarily understand it as well as you do, but they can get you to the right places.
Yeah, I love that. All right, well, this has been a lot of fun. Thanks for joining us today, Mark. And everyone else, thanks for tuning in, and have a good weekend. Testing.